Okay, so today we're going to go over calculating the regular payments of the two formulas, which we found to be present and future value. So we have our two formulas here. The regular payments. Oops, yeah. The regular payments are the R's in both of these formulas. So let's talk about the difference between the two. For instance, in the future value formula, if we're trying to find regular payments, that means we have all the other information, the N, the I, and we have a future value amount. So when we're talking about the future value, I want you to think about it like this. Let's say we would like to have $1 million in a certain time frame. So in the future, in our future value, we want to earn $1 million. We want to do this in maybe 25 years. Okay? So our years are 25. We have a bank account that is giving us, we'll say this is a generous bank account. Okay? And its interest rate, or R, is equal to 3%. That's pretty generous. It's very generous. Okay, so our interest rate is 3%. 25 years, we want to earn $1 million. Our bank account, let's also do something that's a little different because we've been doing monthly all the time. Let's say we got a special bank account and it for some reason compounds weekly. Okay? So when we go to calculate this, we're going to be looking for regular payments per week. Okay, remember our compound period and our regular payments will be the same. So our R is going to be a specific amount per week. Okay? So we're going to have to figure out how much we'll have to invest every single week in order to have $1 million in 25 years. Okay? So we're going to be plugging into this formula. So when we're talking about compound weekly, remember, interest rates are always per year. So this is 3% per year. How many weeks are in a year? That's right. We have 52 weeks in a year. Okay? So that's our C. Our C value will be 52. So we need to calculate our N in this equation, which is years times compound periods. And we also have to calculate our I, which is the interest rate divided by compound period. Now we said we're going to do this over 25 years. And each year is going to be 52 weeks. This is going to be a rather large amount. What is it? 1,300? So what that means is we're going to make 1,300 separate investments. Okay? And we're going to earn interest 1,300 separate times. Our interest rate, on the other hand, is 0.03 divided by 52. So each week, what is our interest rate going to be? And this is going to be a very small number. Oh, sorry, I didn't do that right. 0.03 divide 52. 2. There we go. Oh, 4 decimal places. So there's 3 zeros, then a 5, 7, 6. So 1, 2, 3, 5, 7, 6. This is how much interest we'll earn every week, which is actually something like 0.05% per week. Okay, it's a very small amount. So we're going to put it in. Our future value is $1 million. Okay, we want to earn $1 million. Our regular payments are what we're trying to figure out. We have 1 plus I, which is this value here, 0.000576. Our power is 1,300. That's a very large exponent. Okay, subtract 1, divided by that very small value again. Okay, so the goal to this is to isolate R. We need to figure out what R is by itself. So the very first step is we're going to be moving things to the other side of the equation. We want to move this value to the other side. And when we do that, we're going to have to multiply due to division. So we're going to take 1 million and multiply that number by 1 million. So we still have it in the calculator. Times 1 million. So that's 1 followed by 6 zeros. 3, 4, 5, 6. 576.92. 576.2 is equal to R. We'll simplify this number in here to be 1.000576 to the power of 1300 minus 1. Now we can equate this to be a specific value, okay? So let's put that in the calculator because that number is going to be multiplied by R. So let's figure out what that actually is.
Okay,
We have our one.
We can just put it into the calculator.
576 to the power of 1300. Subtract 1. Where's subtraction? 1.114, let's say. So R times 1.114. Okay? And the number on the bottom we brought over already. The last step to isolate R here is we need to divide. We need to bring this over, so we'll be dividing by 1.114. So it's a rough estimate here. So we take our 576.92 divided by 1.114 equals 51788. So what that means in our bank account is if we invest $517 every week for 25 years, we'll have $1 million in our bank account. Okay? It's a pretty long. So let's say that you guys inherit money. Okay, so you get an inheritance, someone passes away, or you earn a house or something. What would you guys like as an amount? 200,000. That's great. Really? That's a lot.
That's a lot.
Okay, so we inherit $200,000, and we want it to last us a certain amount of time. How much would you like us to last?
2 years. 15 years.
How many? 2 years.
5 years. 5 years.
Okay, 5 years. I actually like 20 years more. I feel like that would be reasonable. So let's say you get this $200,000 right now. So this is our present value, and it's going to last us for 20 years. Okay. We have a bank account. We're going to say this is not a very good bank account, and you're only earning an interest rate of 1%. Okay? This is a normal bank account, say. But because it's a low percentage rate, they've done something very nice for you. And they've decided to compound this daily. Okay? I just want to give you different examples. It's pretty unrealistic, but that's fine. We're going to get daily compounded. Okay. Oh, you might not even be able to use your calculator for that one. Actually, I'm not sure. We'll check. So, our compound period is daily. What does that mean? How many days?
365.
That's right. Our compound period is 365. So every single day you're getting interest. Okay? 360? Oh. 360, we're going to go every day.
366.
Okay, so let's get going here, guys. That's right. So, let's go and talk about how to calculate I. I is the interest rate you're going to earn every day. This is going to be an extremely tiny number. Okay, because our 1% is 0.01 divided by our compound period, which is 365. The amount of interest you earn every day is going to be extremely small, but it is going to add up. So, if you have a calculator like mine, pay attention, because they may give you a number like this, 0.01 divided by 365. Oh, nuts. Always does that. Divide 365. Okay, that says -5, e to the -5. In other words, I got to move this decimal 5 places to the left, which means there'll be 4 zeros in front of this 2. So 4 zeros and then 27, I'm going to say. Okay, so 1, 2, 3, 4, 2, 7. That is how much interest we earn every day, which is extremely tiny. But n being the number of periods, we're going to do this for 20 years. And we're going to do it 365 times a year. How many compound periods are we going to end up with here? 20 times 7,300. So that is many, many compound periods. In other words, we're going to be able to take out money every day. Okay? And we're going to calculate how much money we're taking out every single day when we do this. Okay? So we're taking money out every single day to live off of. So in our formula, our present value is 200,000. Our regular payments are unknown. Okay? Our formula is 1 subtract 1, and I'm just going to add that to it, because we know 1 plus that is just 1.00027 to the power of negative 7,300, all divided by that I value, which is 0.00027. Now, the very first step in order to isolate R is we need to move over what's on the bottom of this equation. Oh, sorry, I missed the 0 on both. Thank you. Okay? Okay, so when we go to multiply that, I need to multiply 200,000 by that small number. Now, I've kept that number in my calculator. No, I haven't. 0.12347 times 200,000. Is that right? Yeah, that's right. 5.4. Really small. Is equal to our regular payments. Now, this part here we can calculate. 23427 negative 7300. We can calculate this all in one step on our calculator. So we're going to turn that into a number. Okay? So that is 1.12347 to the power of 7,300 when it's negative is equal to, and we need to subtract 1 from that number. So I'm going to have to write it out once. 0.82111. Okay, so this becomes 1 subtract 0.82111, still multiplied by R. I just haven't subtracted the 1 from it yet. Okay? So take 1, subtract. Can I take the answer? No, I can't. So 0.82111. 17889. So this is being multiplied by our R. That means I need to move this to the other side. And when I do that, I'll have to divide by this amount. So this is going to tell us every day how much money we can take out to live off of. $200,000, okay? So we divide this amount, 5.4, divided by 1.7889, okay? So we're taking money every day for 20 years out of $200,000. You can take out $3 and a penny. Not an amazing amount from the original $200,000, correct? Our bank account wasn't great, and we're also taking money out every single day. So you need to keep that in mind. I apologize. I made an error here. This should be 0.1.
Oh, yeah.
That's going to make a big difference here. Let's see. We can earn much more than that one now. What is it now?
30.
Oh, 30 bucks. That's better. $30 a day. That's a lot better. Okay, so we